Okay, hello everyone, and welcome to my rearranged session. I hope you weren't expecting to see Marcin Grejak because he's presenting later on. So I'm here to tell you what's happening in Spring and what we're thinking about the whole serverless thing. I don't think I even need to introduce myself. I've been working on Spring for a long time. Recently I've been working on this stuff. So Spring Cloud Function and Project Riff, which I'll talk about and show you hopefully. I better make sure I've got an internet connection before I try and do that. Looks like it, doesn't it? Yeah, that's okay. All right. So I'm going to talk about what serverless means to me. I think if you were in the keynote yesterday, you kind of know that already. But I don't want everybody to do everything in a serverless way. I don't want everybody to do everything as a function. All right, serverless is probably an interesting word to dissect a little bit, right? I mean, serverless means I don't care about the server, and I do think that that's a good principle. But we had that with, platform as a service. Applications that run on platforms have that characteristic as well. So I don't want to split hairs, but I'm mainly going to talk about functions today, not just platforms that support functions, including Riff and Spring Cloud Function. Okay, so serverless means different things to different people. I said this yesterday. I virtually showed the same slide yesterday. But it's probably worth saying again. I think it's important that things are event-driven, right? That's it should be part of the programming model if you're going to deliver business applications on a serverless platform. But it isn't to everybody. Not everybody believes that that's a characteristic of a serverless platform. Scale to zero is important to a lot of people as well, but then not everybody. All right, so there are some serverless platforms that don't scale to zero, and the reason you wouldn't perhaps care about scale to zero would be if you were really intensely focused on latency, because cold starts, and we're going to talk about Spring in a minute, so everybody knows what's coming. If you care about latency, then you kind of want things to be warm, so therefore you don't want scale to zero. On the other hand, if your build per gigabyte millisecond, then you do care about scale to zero. If you've got a piece of functionality like a webhook that you don't expect to be hit more than once a week, there's absolutely no point in having an application sitting there waiting for the webhook. And that's a perfect application for a function as a service. But like I said, that doesn't actually necessarily translate to every platform, and not everybody believes that that's important. If you do, then that's probably because of the billing per message thing. Or actually in Amazon, it's what I just said, it's gigabyte seconds. So the bigger the memory you use, the more time you take. You multiply those two things together and they charge you for that. But the main thing, and I think the main thing for a Spring developer, is this the intense focus on business logic. All right, just no boilerplate whatsoever. I just want to do my business transformation, take some data, extract some meaning, do something with it, send it on its way, and I don't care where it came from. I don't care where it's going to. That's essentially what a function is, and that should be very familiar to anybody who's been using Spring, because that's how Spring was basically designed. It was designed as a way to make developers' lives easier by exactly that, not having to care about anything but the business logic. And then the last thing is it's not really an afterthought, but it's something that I've been thinking about more recently. Just the fact that the platforms that exist for serverless and functions have a rich variety of platform services, so messages and HTTP gateways and database, data stores, transaction logs, things like that, that are very particular to the platform themselves. So they're great, right? They're really nice to use and really interesting, and there's more of them every day. But there's a little bit of tension, especially for traditional enterprise developers, because they might not get much value out of them. If your job is to take an FTP feed of payment data at the beginning of every day and make sure that the payments get made, the fact that the data was in S3 if you're on Amazon isn't really going to help you. You probably don't have access to the Amazon infrastructure if you're doing that kind of job anyway. So I've been trying to think about what that would look like for the traditional Spring user, and hopefully some of the ideas we've been having in Pivotal and in the Spring team will help us to think about that, and I'll explain what I mean later. Okay, here's a screenshot. Amazon Lambda. It's a typical Amazon Web Services console screenshot. It's got, places where you can enter data, and effectively that turns into an API call that uploads code into their platform for you to run. Amazon Lambda, Google Cloud Function, Microsoft Azure, they all have similar features. I'll show you a live example when I've done my demo. And Project Riff, the screenshot's a little bit of a cheat because we don't have our own user interface. This is just a Kubernetes dashboard showing you some stuff running in Kubernetes, and anything I could show that and it could mean anything, but actually this is Riff running, and I'll show you some Riff running as well before we get to the end. So here is a short list of some providers of serverless platforms. So you've got Amazon, Google, Microsoft, Riff, which is a Pivotal open source project, and probably will be part of whatever we call it, Cloud Foundry, at some point in the next year-ish. IBM had a thing called OpenWhisk. Oracle have a research project called Oracle FN as well. OpenFaaS, Fission, Kubeless, those are all a little bit similar to Riff in the sense that they're all based on Kubernetes. So they're Kubernetes based implementations. They have some slightly different goals and different implementation details, and so I can, as I show you Riff, maybe I'll explain what its features are that make it important. From a Spring developer's point of view, one thing to note is the J. So the notation on the slide means if there's a J, then they have native support for Java, which means that you have a good chance of running Spring there, should you wish to. The ones that don't have native support for Java, they tend to be, you can hack or work around it in some way, but it might not be the best experience. So you can always kind of, build your own container basically, and run that. Okay, so if we're Java programmers and we're thinking about function as a service, then we should probably start thinking about Java packages in the JDK. So let's go to the lowest common denominator. What can everybody agree on? And there's more than one reason for doing that. One is because it's a sort of common tool that everybody has access to. It's a standard, if you like. Another is I don't know if I'll have time to really demonstrate this happening, but the architecture of a serverless platform might involve a sort of application server style trick of class loader boundaries. So the thing that accepts the user's data is probably running generic platform code, and it's probably written in Java, so it has a class loader. But the user's function, as a user, I want to package my function with all its dependencies. I want to be able to do Spring and evil side effects and things like that. And I don't necessarily want those two things to be sharing a class loader, but they must share something. So they probably have to share, the JDK is going to be there. The JDK classes are always going to be in a common class loader. So Java util function is a good place to start because it's very widely usable and available. And so then we come to Spring Cloud Function, and many of you probably have seen this before, but let me just describe what's going on there. It's a Spring Boot application. It says, at Spring Boot application, and it has a main method like it usually does, so you can run it, and it has a bean of type function, and that's it, basically. That's Spring Cloud Function in a nutshell. It's a Spring Boot application where there are one or more beans of type function, or consumer or supplier. So those are the three kind of transformation. It's source, sink, and processor, right? The programming models. So I could just show that, I guess, as a demo. But before I do that, I want to mention that as in addition to a bean of type function, in Spring Cloud Function, it's quite a low-level library. It doesn't depend on very much at all. Actually, probably only really depends on Spring Core framework, and not that much indeed of that. So we can do things like this. We can support plain old functions. You can just write a function, a class that implements function, and give us some configuration. We'll tell you. We'll find the classes that implement function, and if you tell us where to look, and we'll turn those into invocable code. Probably, I probably won't demo that per se, but let me just show you how easy it is to get started. Here's a demo from Josh's favorite place on the web, the Initializer. I'm going to use snapshot because I want to use a snapshot of Spring Cloud Function. Spring Cloud Function isn't quite a checkbox. There's a pull request for a checkbox, so it's in that state. I'm going to install a different piece of Spring Cloud, and is that too small still at the back? Shout if it's too small, please. So I don't need Spring Boot snapshot, so I'm just going to sort of back out of that. And I'm going to, instead of using Spring Cloud Starter, I'm going to say Spring Cloud Starter function web. Okay. So that's all I had to do, and that would be in a few days' time. That'll be a checkbox on Initializer, and then I need to go into my application code and create that bean definition. So I'll do @bean. Whoops. Is that already done? Yeah, @bean public function. Let's say something simple, string to string, or call it demo. Return the value uppercase, the poster child demo. I could, if I wanted to, I could write a function of foo to foo. That's another feature of Spring Cloud Function. But then I'd just have to create a foo class, and it would be just as pointless, so I won't do that today. That would be useful for business applications, right? Not demos. That would be what you'd do. So then I've got an app and I can just run it, right? Run as, fingers crossed to everyone. Doesn't matter which one I choose. Java application. So it's running, and because I used Spring Cloud Starter function web, it's started up a Tomcat. Tomcat web server is running on port 8080. So I should be able to go onto my nice shell. And curl localhost 8080 minus d foo. And I'm going to have to tell it explicitly that the content type is plain text. Content type text plain. Try to say text plain, otherwise I'll start typing plain text. Okay, who thinks that's going to work? Yay! So all I had to do was write a piece of business logic, and it was exposed through the web because of Spring Boot. Basically, it's just auto configuration. And it started up pretty quickly. It started in 1.5 seconds on my crappy laptop. So that's sort of interesting. If I was in a serverless platform, a function as a service, something else would be happening. It wouldn't be Tomcat, it would be something else, right, to wrap that code and turn it into something that's invocable. So that's probably a fairly good proxy for what's going to happen. That's the kind of latency that I should be able to expect if I was doing cold starts in a sane platform. Just as since Kenny was tweeting yesterday, I don't know if anybody follows Kenny Bastani, or if they follow me, you'll have seen this. He was, I wasn't going to show this, but but I will, just to show what it means. If I just change that to Spring Cloud Function context instead, so there's no web wrapper, then all I'm doing is finding the function. I'm creating a Spring context, finding the functions and registering them in a catalog of functions as a function catalog. Let's see how quickly that starts up. Okay, so that's Spring Cloud Function doing everything it needs to do in 800 milliseconds on my shitty laptop. If I had my desktop machine at home, which is faster, it would be like half that. So a few hundred milliseconds. Which isn't bad, really, is it? I mean, like, that's what you should be able to expect from a cold start of Spring. Spring Boot, right? It's not just Spring Boot. Well, since I'm on a hobby horse now, I'm gonna show you. The thing that Kenny was tweeting yesterday was in my GitHub micro apps. You will find a relatively new repository called micro apps, and there's one there called micro. There's a few. There's one called boot, one called demo, one called mini, one called micro. The micro one is no Spring Boot, no at configuration, no at component, no component scan, just Spring and Netty and an endpoint that listens for a HTTP GET. Let me just run that for you quickly. I've done a lot of work on JVM startup in the last year or so. Suffice to say, I'm less confused than I was, but I still don't think I've finished. So there's the micro thing. So if you open this up in your IDE and run this thing called micro application, so all I'm doing is creating an application context and registering an HTTP route. So this context.register bean, that's a Spring 5 feature to avoid at configuration and XML and everything that you've ever known about Spring. So it's a relatively new thing. And if I run that, okay, then it starts in, under half a second. So that's what Spring can do. All right. If I ran that on my desktop machine at home, that'll start on OpenJDK. It'll start in about 300 milliseconds. The benchmarks, actually, if you're interested, the benchmarks are all here. There's a link there to the numbers. Why don't I click on it? You can see. So there's some data there. The score is the startup time in seconds. So there's ways that you can tweak it. The micro thing was this. So 200 milliseconds. I played around with the class path a bit and got it under 200 milliseconds. And if you run it on J9, tends to run a little bit faster even. So this isn't the micro anymore. This is the mini that actually uses Spring Boot, and it's running in 200 milliseconds. So that's what you can do, right, with Spring. Don't have to be too scared about cold starts if we work hard at it. Now that's the good news. The bad news is here's my Spring Cloud function sample. If you went in the Spring Cloud function repo and checked out the AWS sample and deployed it to AWS, this is what you'd see. You'd see an uppercase function, and I'd be able to test it in their UI like this. And that isn't exactly instantaneous, is it? What did it take? I was billed for 5,800 milliseconds. All right. So that tells me that Amazon's actually a pretty shitty place to run Java. It's not even as good as my laptop. But on the bright side, what happens if I press it again? Well, in that case, I was only billed for 100 milliseconds, and that's the minimum in AWS. So, a bit of caching, and that's not difficult to do, and you've got a few milliseconds latency, perceived latency by the user. So I don't think you should use this kind of thing for anything that needs low latency, frankly. But that doesn't mean there aren't applications that would benefit from it, obviously. Anyway, there you go. So you can have fast functions, less than a millisecond, right? We can all have fast functions. The same thing on Azure. It's the same sample. It's the sample from the Spring Cloud function repo. That their interface looks a bit busier. It's extremely sluggish and slow on its own. So when I press run here, I might as well go and have a cup of coffee, actually. And I don't know how much of that is. I don't know how much of that is the UI sucking, because it sucks whatever you do. It doesn't. It's not just running functions. It's slow whatever you do. Eventually that'll come back and show me that it can run my Java code. And there's a cache there as well, so I can reduce the latency on the warm starts. Actually, there's one other little trick I can show you in my my demo. So I'll go back to this from the slide demo thing, right? If I change, so this is Spring Cloud function context. When I run that, it takes whatever it took. Oh, that was the server, right? So let's look at actually running this again, seeing how long it takes. So that's just starting Spring Boot in 800 milliseconds. Now, because there's no web server there, the process is exited. So I'm going to just create a block. I'm going to block this from exiting system.in .read next line, is it? Yeah, there we go. So that should now not stop. Okay, so it's running and doing nothing. All right. Why did I do that? Because I wanted to show you something interesting. If I add Spring Boot DevTools, didn't need the version, but there you go, and then run it again. Of course, the first time it starts up in the same, a few hundred milliseconds, 900 in this case. It's a little bit variable. But then if I make a change to the application and recompile it, DevTools restarts it in less than 200 milliseconds, 100 milliseconds. That's a warm start, right? And that's achievable as a cold start if you just had a JVM, with the right class loader sitting there waiting. So that's one of the things that we want to try and do with Riff, for instance, to give users the choice to have we can have a pool of warm JVMs, and we can make them do that, and then they'll have lower latency even for what is officially a cold start for the function. So what if you don't know what DevTools does, it basically has a layered class loader. So you've got the JDK and Spring and everything in one class loader, and then you've got the application in another. And when you restart, you throw away that class loader and build it again, and then start Spring up again. So Spring is starting again, all the classes are loading again, but it's much faster. It's much faster when the JVM is warm. Okay, so let's see what the slides are telling me. Okay, so this is what I measured for AWS cold starts. It's sort of interesting. It's always going to suck, I think. But what's interesting is this. So they charge you for gigabyte seconds, all right? So and they let you control only the memory, which is a bit rubbish because basically, if you constrain the memory, Spring Boot's fine with 100 megabytes of RAM is fine for starting a tiny app like that. But when you constrain the memory, they also constrain the CPU, and that isn't good for a Spring Boot app. It needs some threads to start up. So it has quite a dramatic effect. So this graph here is memory. So it starts at half a gig and goes up to 3 gigs of memory. And you can see it starts off really quite bad, 10 seconds or more start time. That's actually 15 seconds. And it goes down really dramatically. If you double the memory, you get half the startup time. All right. So actually the cost is the same. If every function call was a cold start, this is the cost at the bottom. The cost hardly goes up at all if I increase the memory. And there's sort of a little sweet spot in the middle here. It starts to go up at the end because after a while there's nothing that Spring Boot can do with more CPU even. It'll just start up in the same time. But around about 1.5 gigs, you've got where it flattens off cost-wise. So you can get as fast startup as you want. If all your starts are cold starts, this is where you should put your AWS configuration. Okay, and so back to Spring Cloud Function. So what we hope to achieve with it is all the benefits of serverless, but with anything you want to do with Spring. So you could make your functions as naughty and stateful and produce as many side effects as you want to. You want to inject a Redis database, just do it, right? And then just use it. I think there's some power in that. There's that people will use that even if Java isn't the best platform for low latency functions. They'll use Spring because it allows you to do anything. So for Spring devs, you get a nice place to write your code that is familiar as a Spring developer and all the features of Spring, because the platforms, Amazon, Google, not Google because they don't support Java, Amazon, Microsoft have their own Java SDKs for functions, and they're different, right? They're not Spring and they're not different from each other, so I don't really want to use them if I can get away with it. So I'd rather use Spring Cloud Function. And also for anybody who doesn't want to know about Spring but wants to use Java for functions, then they don't need to know about Spring. They can just write those plain old functions and it still works. And I guess actually the bottom one might have been an important point as well. So it's a uniform programming model for all providers and also sort of native providers, if you like my demo that I did with the Tomcat. We can provide web endpoints and messaging endpoints. So did anybody go to Oleg Shirakovsky's talk earlier today?
No, it's later.
It's later. There he is. Okay, right. So Oleg is going to... Oh, brilliant. It's even better. Okay, so I was supposed to go after him, but now I'm before him. That's brilliant. So Oleg is going to talk about how Spring Cloud Function will become more of a general purpose messaging programming model in the next generation of Spring Cloud Stream. So that's an exciting one to go to. Go to Oleg's talk. It's probably better than mine. It has some nice colored pictures in it. He probably tells more jokes as well, so he's all together. Just go and see Oleg. Just quickly, we also in Spring Cloud Function we built this programming into the programming model. We built into it the notion that the whole thing should be events, therefore not just request response, but streams of events. Generally, events come in streams, so you can. Instead of transforming request to response, you transform a stream of business events into another stream of business events, and the input stream might be, 0 or many, or up to infinite, and the output stream can be again 0 or many up to infinite, and the programmer decides at some level. Although we found actually when we've been implementing Riff, the platform Riff, which is aware of streams, sometimes the platform has to control at least the input cardinality, how many messages you see in the input stream. And the reason to do that is basically kind of sketched out in this code snippet. I can use the publisher, the Flux APIs, to manipulate the stream, and so for instance return fewer objects than were in the request, and that's what I'm doing here. I'm filtering out rude words. Oh, colored pictures, I have them too. So yeah, this just explains kind of the architecture a little bit. If there was an HTTP message or a Kafka message or a Rabbit message or something that you wanted to send to your user function, so the user function, the blue thing, is the only thing that users care about. Spring, it all sits on top of Spring Boot. There is maybe some kind of provider of serverless features like Amazon WebSphere, Amazon Azure, etc. And then there's a little bit of framework glue, which we call an adapter. So it might be that Tomcat thing that I showed you in the demo, or it might be an Amazon SDK specific adapter that just calls the user function. And that's how we've kind of arranged the code. We've got a core, which is very, very small. We've got a Spring Boot aware piece, and then we've got adapters for Spring MVC, Spring Cloud Stream, Azure, AWS. Riff doesn't need one. Riff is built on Spring Cloud Function, so it's kind of native. Oracle FN have their own adapter, their own version of this green layer here. Oh, there's an OpenWhisk one as well, actually, in Spring Cloud Stream, in Spring Cloud Function. So the programming model, in summary, it's beans. They don't have to be at bean. They could be at component. They could be plain old functions of type function, consumer, and supplier. So that's transformation. It's processors, source, sink, and source, I suppose, of primitive types, plain old Java objects, or publishers. And so we support any publisher. Reactive Streams publisher. We also have a little, so number 2 I've already mentioned. Number 3, we have a little sort of parlor trick, which is to take a string, which is a Java function body, and compile it for you, so you can sort of dynamically register functions. It's a bit like the text box in Amazon AWS, where you type your Node.js function. So you could do that with Spring Cloud Stream, should you wish to. We also have a feature, that number 4 there, for dealing with this class loader separation thing. So you can basically say, here's a jar file, and so that's a dynamic thing you can discover at runtime. Here's a jar file, run the functions in it, make them a separate class loader optionally. And then we have these adapters for Spring MVC, Spring Cloud Stream, etc., etc. How much time have I got? Okay, plenty. I did want to show Riff. Maybe I'll show that first. So Riff is, I could show you the console maybe. The screenshot that I already showed you, if I know how to log on. Google Cloud Console. Okay, here's what Google Cloud looks like. Here's my Kubernetes engine. I've got 2 clusters. They're both running Riff actually, but one of them is called Riff. So if I was to connect to that, so connect, it gives you a gcloud command to connect to it. I've already done that. So in my console here, if I do kubectl get deployment, for instance, services, pods, that's probably got nothing in it at the minute, but if I do all namespaces, you will see stuff happening. There we go. So there's stuff to do with Kubernetes itself, and then there's stuff to do with Riff. So the Riff system is running, it's running Kafka. So there's a message broker in there basically, which is going to route all the messages in between functions and between the outside world and the functions. And then there's a bunch of system components to do with Riff itself. So there's an HTTP gateway, for instance, which just accepts HTTP requests and turns them into Kafka messages, puts them on a Kafka topic, and then a function can pull them off. But okay, so actually I'm going to switch to another window, I think. Just let me do that. There we go. If I did the same thing in the default namespace, kubectl get deployment service pod, there will be none. Oh, there's just the Kubernetes cluster itself, the Kubernetes API. Okay, so let me just watch. I'll put a watch on that for reasons that will become clear. And then I'm going to go back to my function and take out that funny DevTools trick that I was doing. I could leave the Tomcat bit in actually. I suppose it doesn't matter, does it? I'll just do that, just so that you can see that it works. The Tomcat won't be used by Riff at runtime. So I'll do that. So I have a function that works. I need to go and use the Riff command line. Oop, what happened there? There we go. Okay. So I was in my demo, which is in a workspace called demo workspace. So here I am. That's the code that I was running. All right. So I just do maven clean install, and I'll get the jar file, right? There it is. So that's a Spring Boot fat jar because I generated it from Initializer. It has all the dependencies in it. Then I can just do Riff create Java, and I need to tell it which archive to use. I think it's -a target demo, and I need to tell it what the handler is. Handler equals, and there's a number of options here, but the easiest one is just to give it a bean name. So I'm just going to call it, that's the name of the bean that it's going to pull out of the context. I think this will work. Everybody cross their fingers. So what the Riff CLI does is create some Kubernetes artifacts for me. At some point we'll probably get to the point where you don't need to see all that detail, and we'll just be building in the cloud somewhere, but for now this is sort of a semi-manual step. So there's some new stuff now in my directory, and I can let's see what's the best way to get it into so this is Syer demo, so I'm going to have to this is the container image for the function, so I have to build this image. Docker build -t. That works, right? Look, something happened. There's a deployment for my function. It's already tried to push the Docker image that I haven't successfully built yet. So Docker push the same thing. I'm pushing it to Docker Hub, which is kind of ugly, but there are ways to push it to GCP, for instance. I just would have had to put more stuff on the command line. So that is a Docker image containing Java function invoker as a base image from Project Riff, plus my code in a thin layer on top. Okay, so then now that's there. Next time this tries to restart, I think it'll probably work. I could probably kick it to do that more quickly. Delete pod. There we go, it's running. See? Actually don't know why it was running. I didn't expect it to run without a message to process. There must have been a message waiting for it. I must have had that left over from earlier. So then I can riff publish -d foo -I for input demo. Demo is the name of the topic that I'm publishing to, which by default is the same as the function name, but you can change it if you want to. -r because I want to reply. And then that does a post to that HTTP gateway that I mentioned briefly. And it fails. Oh no, there we go, foo. And it came back. Brilliant. Why is this interesting and important? Well, one thing that's interesting about it is I could have had a function of flux to flux or publisher to publisher, and then Riff would have just given me, a stream of events. It's aware of the fact that I might want to do that. And that's cool. That's kind of unique, I think, for function as a service. That's one of the reasons that we're doing it. It's also just nice because it's sitting on top of Kubernetes, and everybody knows Kubernetes these days, so that it's sort of a commodity. And what I think people will do with this is they will build adapters, right? So native services like you see in Amazon, but for the enterprise, you could throw one together really quickly as a Spring Boot application. You know, I could write an HTTP a gateway with Tomcat or Netty or whatever, and publish it as an app in that Kubernetes cluster and have it send messages to my Riff functions. Super easy. I don't have time to demo that, but I could imagine basically how you will build up a marketplace in the enterprise of, you know, extensions, endpoints, adapters that are unique to your business environment. You wouldn't get it in AWS because it's not part of their business, but it is part of yours. So I think that's what's going to happen with this kind of platform. Okay, I better finish. So what did we learn as we were developing Spring Cloud Function and Riff to a certain extent? Riff has pushed Spring Cloud Function into some areas that it wouldn't have gone if it wasn't for Riff. So it's always good to have users, right? That's kind of what we have. Spring Cloud Function, we just did an RC1, a 100 RC1, by the way, so please try it, give us some feedback. It works with Spring Boot 1.5 at the minute and 2.0, so you can use either. The reason for that is the Spring Boot 1.5 is sadly a little bit faster than Spring Boot 2, so if you really care about that startup time, Spring Boot 1.5 is actually faster. So that's one of the things we learned, actually. And Spring, as I've shown, I think, in the demo, Spring on its own is not actually slow at all. You know, 100 milliseconds is not slow. It's not really all that heavy either, because it doesn't do much until you tell it to. Right? What's most important, and if you looked at that benchmark blog that I was, benchmark repo that I pointed you to, what you actually find is a very strong correlation between startup time and the number of classes loaded. So the more classes you load, the longer it takes to start up. So that just means features. You pay for features, right? If you want to have Spring Boot and all that loveliness, it's features. You're consuming features, you're paying for it. On the other hand, AWS Lambda containers are pretty much as slow as you want them to be. So let's see if that Azure one's finished. Yeah. So it finished at some point. It probably took about 30 seconds on a cold start. It's sometimes that bad. Sometimes it's not. Sometimes it's, you know, a couple of seconds. It's fine. The Riff one, I don't know if you noticed, was actually it wasn't like instantaneous, but it was pretty zippy, and all it had to do was build that Docker image layer, the file system layer for my jar file, basically. So everything else would have been cached, the Java function invoker, everything. So they can be quite fast. They can be almost as fast as Spring starting up, but that at the end of the day, actually, that's one of the learnings that I should put on this slide. It doesn't matter how fast you can start Spring, because there's always going to be something else going on, right? Somebody's going to be schlepping bytes and, you know, creating resources, and the platform is going to have to do stuff that we don't have any control over. So at the point where you get it to, you know, a few hundred milliseconds, you probably have to stop caring. That's what I've concluded, at least anyway. Warm JVMs start much quicker. I showed you that. And here's the advice for the architects, basically. So functions, they're glue code anyway. They're not really designed to be used for you know, serving UI assets. They're not really, they shouldn't be used in a latency sensitive way anyway. So you might as well use Java and get the most out of Spring. Scale to zero, it's important for everybody, so we do pay attention. We are focusing very precisely on things like startup time and resource usage. And I've shared a few of my views about platform services and what I call integration spaghetti. So getting rid of that, you know, mess of stuff that you have to connect to is a real breath of fresh air, I think, and that's one driver for using functions, I think, in the enterprise. You won't be able to do it, though, until you've got those services set up for yourself. I think that's it. So thank you for listening, everyone. There's a few links there, the project, Riff, Spring Cloud itself. One thing I didn't show you, which I'd be quite keen to show you another time, is the Spring Boot thin launcher. So if you think that your fat jars are wasteful and taking up too much space in Artifactory, you're probably not wrong, and Spring Boot thin launcher is a way to deal with that problem. I used the Initializer, I used Spring Cloud, and I used the reactor. Okay, so thank you.